We shall now learn how to calculate the amount of products in a chemical reaction if we are given the amount of one reactant. It could also be worked the other way around. If we are given the amount of a product or products, then we could work backwards and also calculate the reactants involved. You should know that this presentation will cover part of the requirement for METSEC assessment criteria 10.3D. There are two main learning outcomes, in this presentation. The first is that you will learn how to calculate the mass of a chemical reaction product, given that you have a correctly balanced chemical equation. So make sure that you are fine with your revision on balancing chemical equations. Also make sure that you are up to scratch on writing correct chemical formula. Next, we shall also use mole ratios, from chemical equations. So the chemical equations, once again, must be correctly balanced in order to calculate exactly reacting masses of reactants and products. There is an example in this presentation that explores the reaction between iron and sulfur to give iron 2 sulfide. This learning outcome refers specifically to that reaction, which we shall come to soon. Let's now move on to our next slide. Learning outcomes are, of course, best understood by means of an example. So let me zoom in on the chemical equation that we have right in front of us. As you can see, it is a neutralization type of chemical equation. It's a neutralization reaction between a strong acid, sulfuric acid, and a strong alkali, sodium hydroxide. Go back also to your acids, bases, and salts and alkalis that you would have learned in year 9. Now is the time also to make sure that you are up to scratch with that revision. A correctly balanced chemical equation is necessary. So note that as expected, the sulfuric acid is being neutralized to form a salt. The salt is sodium sulfate. The definition of a salt clearly is when the hydrogen of an acid is either replaced by a metal cation, in this case it is Na+, or an ammonium cation. It could have been NH4+. Now, you know that if the chemical equation is correctly balanced, there is a certain mole ratio. You can see, from the mole ratio that 1 mole of sulfuric acid will react with 2 moles of NaOH, sodium hydroxide, to give 1 mole of sodium sulfate and 2 moles of water. Now, whenever we do a calculation in chemistry, it is critical that the equation is written correctly and balanced correctly. Otherwise, the calculation shall be wrong. The result will be wrong. Now, we are being asked to use this correct mole ratio based on a correct balanced equation to calculate the mass of a product. Should we be given a given mass of reactant? So now let's move on to the next slide, where we are given an exact problem to solve based on this idea. Don't let the text in this slide scare you off. That's why I'm here right in the bottom right hand corner, to make sure that you are encouraged to go through it stepwise, as I'm going to show you in a minute. So let's select the red pen. So whenever we are faced with a problem like this, as I previously said, I would underline the most important parts of the problem. We are being asked to calculate what? The mass of sodium sulfate, which is produced when, as we saw in the previous slide, 20 grams of caustic soda, sodium hydroxide, react with excess sulfuric acid. Now, Many students would be immediately confused. What is excess sulfuric acid? Why am I not being given an exact amount of sulfuric acid? Do not be confused at all. We have all the information we need to move forward. We are being told that there is enough sulfuric acid to react all of the NaOH. Typically, there is more than enough. There will be some sulfuric acid left over. But all we're interested in here is that since there is excess sulfuric acid, all of the 20 grams of the NaOH shall react. Okay? Now, we are also given the relative atomic masses. Okay? Now, in your exam or in your tests at school, whatever, you shall always be given relative atomic masses. But believe me, at this stage of your education, okay, I would expect students to start getting used to relative atomic masses of the more common elements, such as these four, without even consulting the periodic table. Okay? Okay, so the equation is as shown over here. We have the reaction between sulfuric acid and sodium hydroxide to give us sodium sulfate and water. Okay, check out the balancing for yourselves. It is correctly balanced. Remember that since sulfuric acid is a dibasic acid, meaning it has 2 protons per molecule, okay, per chemical species, it will require twice as much of NaOH for reaction. So the mole ratio is 1 mole of sulfuric acid is to 2 moles of sodium hydroxide. The mole ratio is throughout based on the correctly balanced chemical equation. So we know that 1 mole of sodium sulfate is being formed in this chemical reaction. Note that the first step proper in the calculation is to determine the relative formula mass of NaOH, which we do by adding together the atomic masses of each of the 3 elements. Sodium is 23, oxygen is 16, and hydrogen is 1. So the relative formula mass works out to be 40. Likewise, we calculate the relative formula mass for sodium sulfate, taking into consideration that we have 2 sodium atoms. Therefore, we must multiply the relative atomic mass of sodium by 2, and also that we have 4 atoms of oxygen, so we have to multiply the atomic mass of oxygen by 4 as well. The correct relative formula mass for sodium sulfate is 142. Next, what we do is we calculate the actual number of moles of sodium hydroxide, as indicated over here. Now, the number of moles of sodium hydroxide can be found by means of this equation, where we say the mass of sodium hydroxide divided by the relative formula mass expressed in grams. However, this is just a simple proportion, and I prefer my students to understand calculations logically rather than by rote using some form of formula. So let's reason this out, and we'll see how what we reason is exactly the same as what we have underlined over here. So basically, we know that we have 20 grams of NaOH. Now, the relative formula mass of NaOH is determined to be 40. We know that if we had to convert the relative formula mass into grams, we express it as grams, we have the mass of 1 mole of NaOH. So 1 mole of NaOH, okay, equals 40 grams. Remember, we are expressing the relative formula mass as grams, in terms of grams. So 1 mole of NaOH has a mass of 40 grams. Now, in the experiment, in the actual experiment, we do not have 40 grams, we only have 20 grams. So clearly, since we have just half as much, we must have half as many moles. So how many moles of NaOH? You don't even need to work the proportion using any form of calculator, right? You can do this just mentally. 1 mole is 40 grams, therefore 0.5 moles of NaOH is equivalent to 20 grams. So we start off with 0.5 moles of NaOH, and I would strongly suggest that you write that on top of your NaOH so that you know what you have calculated so far. So what is actually given to you when we are talking about 20 grams of NaOH is 0.5 moles of the substance. This needs to react with sulfuric acid to produce sodium sulfate. Now, how can we determine how much sulfuric acid reacts with it? The mole ratio is 1:2. So since 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide, therefore, keeping the same ratio, 0.25 moles of sulfuric acid will react with 0.5 moles of NaOH, and they will produce in turn, so notice the mole ratio, I'm always consulting the mole ratio, 1 mole of sulfuric acid, 2 moles of NaOH will produce 1 mole of sodium sulfate. And we are actually being asked to calculate the mass of sodium sulfate, so more relevant to us than the moles of sulfuric acid are the produced moles of sodium sulfate. Since the mole ratio is 2 of NaOH is to 1 of sodium sulfate, therefore, since I have 0.5 moles of NaOH reacting, I must have 0.25 moles of sodium sulfate produced. So this is getting somewhere. Okay, so now we know that we have 0.25 moles of sodium sulfate. Now remember what we said. We said that the relative formula mass of sodium sulfate is 142. Therefore, if we had to convert the 142 into 142 grams, that is the mass of 1 mole of sodium sulfate. Do we have 1 mole of sodium sulfate? No, we don't. All we do is 0.25 moles. So the produced amount of sodium sulfate is 142 division by 4, a quarter of the amount. And that works out to be exactly 35.5 grams of sodium sulfate. In other words, that is the 0.25 moles that we produced by means of that chemical reaction. Okay, so 0.25 moles of sodium sulfate and 35.5 grams of sodium sulfate are the same thing. Okay, 0.25 moles is the number, and the number of sodium sulfate species will weigh that much mass. So this is the type of reaction that you are expected to apply, and you will use this type of chemical equation to derive the mass of a product given the mass of a reactant. This is according to your METSEC assessment criteria 10.3D. Let's now go on to the next slide. There is another very important type of chemical reaction. Basically, it's the same idea as in the previous, but it is best if I go through this as a separate example. Let us consider now the reaction between two elements, between iron and sulfur, to give iron 2 sulfide, as we have in the first bar, where we've got the chemical equation written out for us. Okay, the chemical equation is a balanced one. We've got 1 mole of iron reacting with 1 mole of sulfur to give us 1 mole of iron 2 sulfide. Now, the problem itself is given in the second bar over here. We are being asked to calculate the mass of sulfur required to react with exactly 1000 kilograms of iron metal. So 1000 kilograms of iron metal is given to us. What we do not know is the mass of the sulfur in kilograms that is reacting with it. So that is the first part of the problem. The second part of the problem is where you are being asked to calculate the mass of the iron 2 sulfide formed. Okay, so should I have 1 mole of iron reacting with 1 mole of sulfur to give us 1 mole of iron 2 sulfide, maintaining that ratio? If I am given 1,000 kilograms of iron, okay, how much sulfur does that need to react with, and how much iron 2 sulfide will be produced? Okay, now it's not a difficult calculation, but we shall walk through this step by step. The first thing that might probably confuse you is why is the examiner using such enormous quantities? And what I always tell my students is this: remember that chemistry is not just designed for the school laboratory. The chemistry you learn at school is preparing you for potentially being chemists working in the chemicals industry, where much larger than lab-size quantities are used, okay, in the production processes. So this drives home, this problem drives home that what is applicable on the small scale can also be extrapolated to a production-sized scale. Now let's go to the solution of this problem on the next page. The first part we shall work together during the presentation. The second part, let's deal with it as a homework. Okay, so that will be your job to do the second part. But if you know how to perform the calculation right with the first part, the second part should be quite easily solved by you at home. So now we shall work together the first part of the calculation, part 1. Part 2 is up to you, okay? I would strongly recommend that you would try it immediately after having seen this video presentation. If you get into any difficulty, then I would definitely suggest that you consult your class teacher to help you out with it. Now basically, the problem is based on the correctly balanced chemical equation, which is indicated once more over here. All right, notice that we have the mole ratio is 1 mole of iron is to 1 mole of sulfur is to 1 mole of iron 2 sulfide. We are being asked, the question is right over here, to calculate the mass of sulfur, okay, which is required to exactly react with 1,000 kilograms of iron metal. Now do not get confused by the huge amount apparently of iron metal. Remember that chemistry is not meant just to be studied to pass an O-level exam. Chemistry is meant to be applied to real-life situations. And those of you who will continue with their chemistry studies and also perhaps in future use chemistry for their employment might end up in the chemicals industry or in the industries related to use of chemicals where big quantities, many kilos, not just grams, are used. So this will also prepare you for such a possibility in future. Okay? Well, let's get to step 1 of our calculation. Okay? We are first required to convert the mass of iron metal that we are given, the 1,000 kilograms, into moles. This is a standard practice. Whenever you are given a mass of a substance in a chemical equation, you should always think of converting to moles first. Why is this? Because the chemical equation is telling you, listen, you have 1 mole of iron is reacting with 1 mole of sulfur. It does not tell you 1 gram of iron reacts with 1 gram of sulfur, so there is no way that you can get any further until you convert your masses into moles so that you can compare substances together. The amounts of substances together can only be compared once you have converted the masses into moles. The masses into numbers. Remember that moles are the way that we express numbers in chemistry calculations. So remember, the relative atomic mass of iron, which you obtain from your periodic table, of course, is 56. If I express it as 56 grams, you should know that that is the mass of 1 mole of iron. So by simple proportion, if 1 mole of iron weighs 56 grams, therefore, how many moles of iron do we have in 1 million grams? 1 million grams is, of course, 1,000 kilos. Notice, we have to keep the same unit. If we are starting the calculation in grams, we have to finish it off in grams. You cannot simply say 1,000 kilograms, otherwise everything works out to be incorrect. Okay, so by simple proportion, 1 million grams will contain 17,000, are contained rather, well, 1 million grams are what you have in 17,857 moles. Now, I have quoted the answer to 3 decimal places. Usually that should be enough, okay? When you have 2 to 3 decimal places, okay, kept, okay, that should guarantee enough accuracy for a correct calculation. The next step is to calculate the mass of sulfur that exactly reacts with this many moles of iron. So remember, we have 17,857 moles of iron in 1 million grams of iron. Now, that many moles of iron will react with a certain number of moles of sulfur. And how do we find out the number of moles of sulfur? Once again, all we have to do is to look at the correctly balanced chemical equation. Remember that the chemical equation is telling us a very important thing, that 1 mole of iron, 1 mole, will react, okay, with 1 mole of sulfur. Okay, and that will give us also 1 mole of iron 2 sulfide. And that is why we have to convert from grams or kilograms into moles, because then we can apply the chemical equation to solving our problem. Since we know that 1 mole of iron reacts with 1 mole of sulfur, therefore, logically, if we have, as we have, 17,857 moles of iron, they will react with as many moles of sulfur. The ratio has to be kept 1:1. So the reacting moles of sulfur are also 17,857.143. But 1 mole of sulfur weighs differently from 1 mole of iron. Sulfur is a lighter metal. Sulfur has a relative atomic mass equivalent to 32. When we express that in grams, that is the mass of 1 mole of sulfur. Therefore, the second part of this calculation is also a simple proportion. 1 mole of sulfur weighs 32 grams. We know that we have 17,857.143 moles of sulfur. So how many grams do those weigh? And they weigh this amount of grams, 571,428.571 grams, or in other words, 571,428 grams, which works out to be 571.429 kilograms. Notice that since sulfur is a lighter element than is iron, therefore we have a less mass than 1,000 kilograms. 1,000 kilograms of iron will react with a lesser mass of sulfur because sulfur is lighter. By how much? 56 grams of iron will give us 32 grams of sulfur. Okay? That is the ratio. Okay? For every 56 of iron, I have 32 grams of sulfur. So if you had to use a calculator, if you divide 56 by 32, the answer should be exactly the same as dividing 1,000 kilograms of iron division by 571 kilograms of sulfur. You will maintain exactly the same ratio. Okay, so 56 all over 32. 56 grams of iron would react with exactly 32 grams of sulfur. Why is that? Because 56 grams of iron is 1 mole of iron. It would react with 1 mole of sulfur, which weighs 32 grams. Therefore, when I divide 56 on 32, and I would determine the ratio of the masses, then I would expect 1,000 kilograms of iron to maintain perfectly the same ratio when it reacts with 571 kilograms of sulfur. So this concludes this presentation. I strongly recommend that you try out the second calculation, where you will calculate the mass of iron 2 sulfide formed when the amounts of iron and sulfur react completely. As I said, if you are in difficulty about this, please do consult with your class teacher. Thank you for watching this presentation, and goodbye for now.